is a sixth dimension beyond that which is known to man. It is a dimension as vast as space and as timeless as infinity. It is the middle ground between light and shadow, and it lies between the pit of man's fears and the sunlight of his knowledge.
Good afternoon, and welcome back to the Telecom Zone. I'm Sonny Hunt, you'll be your host for this episode. We have a lot of choices out there for field connectorization, a lot of different options to choose from. So today I have my co-host, Joe, here to talk to us a little bit about the different options that we have for field connectorization.
Thank you, Sonny. Thanks for having me again here today on the Telecom Zone. So there's a lot of different connectors that are out there, but we're going to break them down into about 3 different groups. We got mechanical, anaerobic, and epoxy, and the Splice Variety.
Awesome. Well, I know that with each one of those groups, there's different choices that we have. So I'm also interested to learn from you which application we would use them for out in the field, as well as how they operate and how we actually connectorize in the field. So I'm looking forward to seeing your demonstration on those.
Thank you.
So Joe, I see you have some mechanical splice options here for us. So why don't you select one of your favorites here to get started with, and let's tell the audience about it.
Okay, very good. So we have the first here, like you said, these are mechanical splices, okay, not to be confused with a connector, because there's a mechanical splice and also mechanical connectors. But let's go over the splice first of all.
Okay.
So back in the day, when you would have a fiber breakage, they, and splicers were very expensive. A way to get the job or the fiber fixed in a relatively quick period of time and less expensive, they had mechanical splices. So that's, there's a couple different varieties here. And basically what this mechanical splice is used for is you can take 2 pieces of fiber that are broken and put them back together to get your network back up and running. The only thing is you need with the mechanical splice, like with all connectorizations, actually you need your cleaning wipes, you need alcohol, you need a scrap container, and you need strippers on any of these types of connectors and splices that we're going to use. So what you end up doing is you have to prep the fiber on both sides. You're going to strip it, clean it, and you're going to use a cleaver. Now there's 2 types of cleavers. You have your basic cleaver where you put your fiber in, squeeze it, flick it, and that actually scores and breaks the fiber.
Not quite as accurate as the other type of cleaver you have here.
Correct. Or you have a high precision cleaver where you're going to get much better results. And the one main factor you want to remember with your mechanical splices are the cleave. The cleave is the critical key to everything. If you have a bad cleave, you're going to have a bad mechanical splice. Because again, it's mechanical. You're not actually fusing the fiber together. It's a mechanical, you're butting the fibers, the cleaved ends up to each other.
So after you've done the cleave, how would you recognize that you may have a bad cleave?
You really can't tell, and that's you have to trust that you have a high quality cleaver that's calibrated and it's giving you good cleaves, and you got to make sure that would be the case. That you make sure that you service it properly, you advance the wheel,
change the blades occasionally.
Exactly. Yep. So, and that'll keep it in great working order. This is less expensive. It'll get the job done, but you can see the difference between precision and not as precise.
So again, you might say that back in the day, this was probably the smaller cleaver there was what everybody was used, but we've really migrated and gone beyond that at this point.
Correct. That's a good point. So like I said, here's 3 different types. Again, they all use basically the same concept here. You cleave both ends of the fiber, you slide them in, and in this case, you would squeeze down on top of it, and that would lock the 2 fibers in position.
And how well does that protect the fiber when you're doing a mechanical splice like that, Joe?
It protects it. It adds rigidity here at the splice point, and it keeps it from bending. And that's the main thing. You want your fiber not to bend and move, and that's what it'll keep it locked into place. Another type of different variety of mechanical splice. Again, you put the fiber in one side here, you put the fiber in the other side here, clamp it down, and then you're done.
Okay. And would these normally be inside of a tray or an enclosure when you're doing this?
They would either be in a tray or an enclosure to keep them protected, and so there's not a lot of movement. And then you have this third type here, which is kind of a pretty interesting type of mechanical splice. It's got 2 keys in the end of it. slide the keys in, twist, and that opens up the splice. You put your fiber into one side, relieve it, and it will clamp down that side. Open up the other side, slide your fiber in until it butts up, and relieve that little key, and that's what puts it together and locks it in place. So it's just a different type of mechanical you can do, and you can actually fine tune with this a little bit. If maybe you're not getting all the light through, you can actually fine tune it. You can loosen it up and move it back and forth and push it and make sure that it's making that good connection.
Okay. And again, with these type, there's no glue or anaerobic or epoxy.
No. The only thing that is, in fact, with this particular one and this particular one, and maybe in this one also, there is an index matching gel in the middle of that. It's like you can think of it like a Vaseline type material. And what it does is, since there's going to be open air, when you put the two fibers together, it's supposed to even out and it's index matching gel for the index of refraction. Instead of it going directly from fiber to air, it's going through that index matching fluid to help out with the loss and attenuation.
Oh, great. All right.
So, but that's your mechanical stuff. And a lot of times these are, again, think of these as a temporary. They're not really supposed to be for permanent. Generally, you would put these in to get your network up and running, and then when your maintenance window comes through, you come back and you actually do a fusion splice.
So quick fix versus long-term by using a fusion splice.
Correct. So that's mechanical and mechanical splices. Then you come along to mechanical connectors, and there's a couple different types of mechanical connectors. Same concept as your mechanical splices, but this is for if you have a broken or damaged connector. So what you end up doing is the same type of thing. You need to use your high precision cleaver.
Mm-hmm.
You get your connector that comes with the bag here. You cleave in the fiber.
And did these come in LC, SC, ST, FU connectors?
Yes, they come in all different connectors, styles, multi-mode and single mode. And these actually have fiber inside of them, and there's a polished connector end already on the tip, so you don't have to worry about polishing the connector. Again, you're just worrying about the back end of it where you're sliding the fiber in after you've cleaved it. This already has cleaved fiber on the inside and polished end face. You slide that up. Again, there's a mechanical pinch or clamp that goes down on it, and after you put your boots and then you put all the other pieces together and you crimp it, now you have a mechanical connector. Again, it's a mechanical. It's not spliced. It's not fused on or anything like that. It's still a mechanical connector. But again, it gets you back to that point where you're up and running. It's quick, and that's what it's made for. And there's a couple different varieties. This particular one by AFL is your Fast Connect. That has a little clamp feature on it that you press it down, slide your fiber in after you've cleaved it and prepped it, and then once you let that clamp go, it comes off, it locks the fiber in place.
So, Joe, I know in one of our other episodes we looked at video inspection probe. Can I use the video inspection probe on these mechanical connectors as well?
You can. The one thing that you got to remember about these mechanical splices is the end face is already polished for you. So you will still use your inspection probe, but you'll be able to see that the end face is in good condition, and you can actually do it even before you put the connector on. Again, you got to gather that these are in great condition when you receive them. Doesn't hurt to take a look with your inspection probe to make sure that the end face is still in good condition before you go and take the time to actually do the mechanical splice and then plug it in and find out, it was damaged before I even opened it up. So, but that's your mechanical splices and your mechanical connectors.
Okay. And Joe, just from a cost standpoint, what are we talking here on the mechanical splices? What in prices could range from what kind of price?
Mechanical splices are about $7 to $12 a piece.
Okay, so fairly inexpensive.
Yes, and your connectors, they're around $12 to $16, $17 a piece.
Okay, great. So thanks for that.
You're welcome. Just to review, I have the 3 different mechanical splices here to show you. This is the one that uses the 2 keys that you can pry both sides open at different times, so you can put the fiber in individually. These 2 types of mechanical splices are ones that you're going to put the fiber in and then you're going to clamp down either with a tool or with your hands. These guys here, both types here are mechanical connectors. This is the AFL Fast Connect. This uses a little clamp method that you press down, you push your fiber in and let the clamp off, and then you're done with that guy. And this guy here, this is your Unicam connector, and this happens to be an SC. This requires a crimp after you slide the fiber on, and after the boot's on, the fiber's pushed through, and you crimp it, and that puts together, and you kind of have to build this connector a little bit, where this guy here is already kind of pre-built. And then also to review, you got your two types of cleavers here. You got your high precision cleaver, which is highly recommended with mechanicals. And if you're out in the field and this is all you have, this is what you got. This will do the job, but it's not going to be as accurate as this guy.
So that covers just about everything with mechanical. So now what we're going to do is ask Joe to take a look at epoxy and anaerobic style connectors. Joe, what do you have here for us on that side of the world?
Okay, as you can see, I added a couple more toys to our toolbox here for epoxy and our anaerobic connector. So there's about 3 different types that I'm going to review here for you. So one of the things I want to point out is now you can see the introduction of polishing paper, and there's multiple grits.
So it's like a sandpaper?
Correct. It's like a sandpaper, and it's actually, some of these are diamond, some of them are silicon carbide. So it's different types of polishing, thick, you should say grits.
Like coarse to fine, like
Correct.
you were thinking about normal sandpaper?
Exactly. That's used with a polishing pad and a polishing puck. And also we're going to use a scribe to actually score and break the fiber before we go and start polishing it.
As opposed to using a cleaver, or?
Correct.
Okay.
This is used at the end of the fiber that's going to be protruding out. Cut that off so you can now polish it down. Otherwise, if you just break the fiber off, it'll actually crack and go down into the connector, and you're going to have to start all over again.
Okay.
So
very important tool then.
Yes, it is. So let's get started with now. So the first time, this is an anaerobic style connector here, and as you can see, it's there's a couple different parts in here. You got your connector in here. You got a boot, and also a crimp ring that you're going to use. So this is also you got to use a crimper, which would be here. Okay. So the object of this is, again, you're going to use your tools that we used before, and we're going to prep the fiber. We're going to strip the fiber. We're going to clean it. We're going to cleave it, and then what we're going to do is we're going to take the actual connector. We're going to put the. This is actually, there's 2 things here. We have a primer, which is here, and this is a resin or hardener. Mm-hmm. And these things combine, and that will become hard. That will, as it dries, and it will be stuck into the connector, so the fiber can't come out, and that's what's going to enable it to hold into the fiber. So, and that is accomplished by, obviously, you can use a syringe to push it up into the connector end face. You'll put the fiber up with the hardener in there, and then you'll actually you put the hardener up into the connector first, and then you take your prepped fiber and you put the primer on there, you paint it on there, and then you slide it up there in a twisting motion. And as you're sliding up there, that will cause the chemical reaction that will start making that to harden.
So, Joe, that actually sounds a little complicated. Is this something you have to do multiple times to get a skill at putting together? If you have the right amount of epoxy or not enough, I am assuming you don't have a good connection.
It does take practice, because if you're going through it and you have an issue with any one of these steps, you could ruin the connector, and you're going to have to start over again. And that's even before you start polishing.
When you say start over again with the same connector, do you ruin that connector and have to start with a new connector?
You ruin the connector and you have to get another one.
So it can be really expensive if you're not careful with what you're doing.
Correct.
The hardener that you have there, does it? You have to be careful with tightening the lid. Will it dry out?
Yes, there's 2 things you have to worry about, both the hardener and the resin. You have to make sure that you put the caps back on when you're done using them, because they can dry out. And the other thing is there's a date code on it that once you open it and expose it to the air, it'll eventually start to degrade, and then after I think it's a year, you can't use it anymore.
Will it also degrade in the connector too? So if I did a good connector a year from now, 2 years from now, does the connector ultimately fail?
It does not fail, but it also depends on how good of a job you did when you were going through and connecting the connectorization process. So you want to take your time in doing it, but you want to be methodical, and you want to follow the directions and make sure everything's clean. And but these things are supposed to last for up to 20 years.
Oh, okay.
If they're done properly. So that's the anaerobic type connector here. Now we can move on to one that's an epoxy. It's an epoxy-based connector. Okay, and this connector comes along again. The connector comes with epoxy inside the connector. Okay, and you're going to actually put the connector inside this heater here. So you're going to also need a heater. Okay, and that's going to heat up the epoxy. And basically what it happens is as this is heating up, the epoxy starts expanding and rising to the top, and then you can see it bubble out on the back of the connector. That's when you know it's time to get your prepped fiber that you already have waiting, and you slide that prepped fiber up in a twisting motion until it comes out to the end of the connector, and then you put it actually into the drying racks here to let it cool, and then that cooling process will harden. And then you have to go through and use your cleaving tool to cleave off the glass, and then use your polishing papers with your polishing to polish the connector to the proper.
So Joe, I see your heat oven looks like it has an electrical outlet in the back. I'm assuming that you would need AC power in order to generate this. So if you'd need to have an inverter in your truck or something where you could actually heat this up, or does it run on battery?
No, it does require an AC cord or an AC source or an inverter from a vehicle. So yes, that's an important thing to know. But again, this is another type of connector that is using the polish technology, and it's using epoxy. Again, these two types, and we'll talk about the third type. These are permanent. Once this is done, it's supposed to last for 20 years. That's what they were designed for.
And is this still a popular style of connectorization in the field? Are we still seeing people out there doing the polish and the epoxy connectors?
You are still seeing that, but it's slowly becoming, this is older technology, because as I'm going to show you in a little while, there's some newer technologies that are out there. If you're doing one or two of these, it's not so bad. When you have to do 50 or 60, you can just imagine how long it will take, and it is a slow process.
Yeah, I was just thinking from your example here that the time of putting these together probably is, a lot more than some of the other technologies we have. So it's probably, I could certainly see we're moving forward in the future. This would not be the preferred way to connectorize.
No, it is not. But, as everything starts, it starts small and gets larger, and technology gets better with what you're working with. And that's where improvements are made. And hopefully I'll be able to show that in the next couple connectors that I'll show you.
Awesome.
So the last type of connector, this is more totally epoxy based. And this is a two-part epoxy that you get. And you will mix this up. Put the epoxy in the syringe. Put the epoxy into the connector here. You'll see that there's the connector pieces. You'll put the epoxy into the back of the connector, and then with your prepared fiber, like all the other processes we've done before, you will slide that up. And in this case, there's a couple different types of epoxies that you can use out there. There are, in this case, this is a heat cure. So you can use your oven again here to cure the epoxy to make it harden. There's also room temperature curing epoxies. Advantages and disadvantages. Room temperature curing epoxies have a longer work life that you can, as you're putting the fiber in.
You don't have to worry about it drying out so quickly.
Won't dry out so quick, exactly. Whereas the heat-based ones, it's going to take a little, it's a little less time. So they call it pot life. So that's generally what you have to watch out for. But in any of these cases, you're using temperature or in the case, even though it's room temperature, it's temperature to cure the epoxy. So once it dries, again, you're using your scribe. You're going to nip off the fiber that's protruding out, and then you're going to go through your polishing process again. Same type of process as this connector type here with the hot melt, and also with the anaerobic.
Just a quick question while I'm thinking here. Let's say we're December in Minnesota and we're out in our truck doing this, and you're saying it's room temperature. What happens if the room temperature is 0 degrees?
No, in that case, that's not a good time to pick a room curing or room temperature curing epoxy. In that case, you're going to use an oven base. But there's reason. They've made different reasons for different epoxies, and some of them cure faster than others. And if you have a lot of time, then you don't need your heater if it's a room temperature, if you can wait overnight or whatever.
So you really need to understand your environment with these connectors as well as just the different applications that they may work in.
Correct. But again, this is these are labor intensive and they are time. They take a lot amount of time.
Like me, they're old school.
Exactly. but again, they're permanent. They will, these will last long. They're not made as a temporary solution.
Great. Thanks, Joe. So we've mastered mechanical splices. We've taken a look at anaerobic and epoxy. So the last type that we're going to look at here is going to be Splice-type technologies for field terminations. So Joe, what do we have in that category?
So the last two categories, or the last category we have here is the splice technology. And I have two forms of connectors that we can use. And the technology that we're stressing here is splice. There's no epoxy. There's no mechanical. There's cleaving still, but when you put the two fibers together, it's a splice connection.
So I'm assuming that means we just have less potential for less loss than we would with some of the mechanical options we've looked at.
Correct, and you don't have to worry about messing with any epoxies, and you're
also going to faster to do these in the field that way.
Exactly. So now what we've introduced now, what we're going to do is we're introducing a splicer here. So, you have an added cost here versus the other connectors, but you're going to make that up in the time it takes to put these connectors in because you're not polishing. And all you're doing is cleaving, prepping your fiber, cleaving it, cleaning it, putting the fiber on one end, and either the pigtail on this side or the splice on connector in that side, and you're fusing them together, and then you're done. And outside of heating it, so you're using splicing technology with already pre-terminated connectors, and that's what we have to make sure that we get across here. That's really important. Is all these connectors are pre-polished and ready to go. What you're doing is making a fiber splice together, and that's how you.
So you have higher cost up front compared to the others, but cost savings and time savings over the course of the life of doing field work.
Correct. And the other thing is less attenuation or loss.
Higher quality.
So it's going to have higher quality, and it's going to be reliable. And you're going to put these in. It probably takes about a good splicer can probably do these in like 60 seconds or less.
And Joe, we really haven't talked about it, but all these types of connectorization, do they work on single mode and multi-mode fiber?
Yes, they do. They do. So it's just a matter of finding the correct connector style you need and the mode of the fiber, whether it's single or multi-mode. And the same thing can be accomplished with your splice-on connector. And basically what you want to know about the difference between the pigtail and the splice-on connector is a splice-on connector is almost like a short pigtail, if you can look at it that way. They both have polished ends, and the one nice thing about these guys is they come with polished end, and the other end of the fiber that you're going to splice is already cleaved. Okay, so you don't have to bother doing anything with this connector other than putting it in your splicer, getting your fiber that you've already prepped, put in the splicer, and hitting and closing the thing, closing the splicing.
And Joe, does every splicer have the ability to do splice-on connectors?
Not every splicer does. Some splicers do, some splicers don't. And that's going to be important to know when you are purchasing a splicer and you're going to plan on doing splice-on connectors. You got to make sure that the splicer will do splice-on connectors. And there's a lot of different varieties out there. Some come with they have a fiber holder already on each one. Some come with you have to change out the fiber holder on the actual splicer. So it has to make sure that whatever splicer you select, and if you're going to do splice-on connectors, that it will fit your application.
Okay. And will every splice-on connector fit with every splicer? If the splicer has the ability to do a splice-on connector, do you have to be concerned about which splice-on connector you actually purchase?
No, you don't, because the way that these work is there is a universal holder with a lot of these splicers, and as long as the universal holder fits the connector that you're using,
then it would
then
work.
it would work.
Okay.
So, but that's basically it. This is pretty cut and dry with these guys. Again, you're going to get your high precision cleaver when you purchase your splicer. So that comes as a kind of a package deal. So when you're doing your pigtails or you're doing your splice on connectors, again, your high precision splice or cleaver is going to make all the difference.
Okay.
And
Great.
you'll actually be able to see your cleave when you put the two fibers in the machine. When you close it, that's one thing you're able to see when it's actually going through and doing the splice. You can see how good the cleave is.
Right. And I assume if the cleave is not bad, your splicer would let you know, and then you can go back and re-cleave.
Correct.
All right. Well, Joe, I appreciate you taking the time to be with us today to walk through these different connector styles. And thanks to the audience for joining. I hope that you enjoyed this presentation as well. Remember, at fiberoptic.com, we offer all of these products for sale. And if you're interested and you want to learn more about these through the Fiber School, every type of connector you've seen here today is actually covered as a lab exercise. So, if you don't get what you need from the video and you need more practical hands-on instructor-led, we have that ability for you as well. Just check out the number below in the website. And again, if you had any suggestions for us from the Telecom Zone of any particular subject you'd like for us to cover, please send that to us as well. Thanks, everyone. Have a great day.
Thank you.